Hello everyone, welcome to today's session. So, in this session, we will discuss about resolution. First of all, it is necessary to understand that what is resolution. A resolution of a sensor is basically the smallest change that the sensor can detect in the quantity that is measuring. To simplify this, we can understand resolution as capability of a sensor to distinguish any slight change that is happening in the reflectance or in the visibility of any particular object or phenomena that is being captured by the sensor. So basically, there are four types of resolution. First is spatial resolution, second is spectral resolution, third is radiometric resolution, and fourth is temporal resolution. Now, spatial resolution deals with what and how much details are being captured by the sensor, whereas spectral resolution captures the information about that how much capable the sensor is to detect the type of spectrums on or the color bands. Radiometric resolution depends upon or radiometric resolution works for detecting the shades of gray that can be visible in a satellite image, whereas temporal resolution works on the principle of time, that how much time is taken by the satellite to capture a single area again and again. Now we will discuss about these resolutions in detail. First of all, we will discuss about spatial resolution. There is a figure which shows four types of resolution: spatial, spectral, temporal, and radiometric. So spatial resolution. Spatial resolution basically describes that how much details in a photographic image is visible to the human eye. Here is Here is a picture which shows three different types of satellite imagery showing high spatial resolution, medium spatial resolution, and low spatial resolution. As you can see very well that in the high spatial resolution imagery, we can detect various types of features like forest, settlements, roads, etc. Whereas in low spatial resolution imagery, we cannot detect any kind of feature. So basically, the concept of whole spatial resolution is based upon the pixels. It says about the information a pixel can capture of a particular ground area. Or you can also explain the spatial resolution as the ability of a sensor to distinguish between two distanced objects. So we will understand this with one example. Suppose there are two satellites which provides satellite imagery on two different spatial resolution. One satellite provides spatial resolution of 5 meter, whereas the second satellite provides the spatial resolution of 30 meter. Here, if we ask you a question that whose spatial resolution is finer, then you must say that the resolution of the satellite which is providing 30-meter resolution is finer, but it is wrong. The satellite which is providing the spatial resolution of 5 meter will have a finer resolution in comparison to the satellite providing 30-meter resolution. Why so? Because as I have said that it is the ability of a pixel to capture ground area. So now suppose that a satellite imagery which is providing 5-meter resolution, that means each pixel in that satellite imagery will capture an area of 25 meter square on the ground, whereas the satellite imagery which is providing the spatial resolution of 30 meter square, will capture an area of 900 meter square on the ground. So if we compare 25 meter square and 900 meter square, then obviously there will be much more details in the satellite imagery providing 5 meter spatial resolution than in comparison to the satellite imagery providing 30 meter resolution. Now, why so? Because the basic principle working behind spatial resolution is this. A ground area, a pixel which is showing 25 meter square ground area in one singular pixel will only show all the details of 25 meter square area only with one single DN value, whereas the satellite imagery providing 30 meter resolution will show the features that are spread over 900 meter square on the ground as a single DN values, which will lead to a loss of many much detailed information. So this type of resolution is known as spatial resolution. Smaller the size of the resolution, better the finer details. More the size of the spatial resolution, coarser the details. Now, after finishing spatial resolution, we will move on to spectral resolution. The term spectral is derived from spectrum, as we have already discussed electromagnetic spectrum and about the spectrum. Spectrum means basically an array of wavelengths. So, spectral resolution deals with the wavelength or the parts of wavelength, or it can also refer to number of bands in which sensor can identify the details. Suppose here is an example. Suppose there are two different satellites. Number A is providing data in 3 bands and number B is providing data in 6 bands, 6 color bands. So now which satellite will be providing much detailed data? The answer will obviously be the satellite B, because it is providing the data in more number of bands. So this is what is known as spectral resolution. For example, there are multispectral imageries available on the internet and there are hyperspectral imageries also available on the internet. Multispectral imagery generally have 4 plus bands in it, like red, green, blue, NIR, SWIR, etc. Whereas hyperspectral imagery consists of more than 100 bands. So obviously the hyperspectral imagery provides better resolution data than the multispectral imagery. So this is the discussion of spectral resolution. Now we will move on to radiometric resolution. Radiometric resolution basically works on the purpose of principle of bit system. So what is bit system? If we say that a sensor is working on one bit system, then it means there will be two shades of color that will be represented in the whole imagery. Now where is that 2 come from? Bit system means 1 to the power 2. So if we divide, so it means 2. So the bit system is the basic principle working behind the radiometric resolution. Imagery in this radiometric resolution, imagery data are represented by positive digital numbers which vary from 0 to a selected power of 2. The bit system can be 8-bit system, the bit system can also be 16-bit system and much more. If our sensor is working upon 8-bit system, then there can be 256 shades of a particular color that will be found in that imagery. So the radiometric resolution basically works with the shades of any color. Suppose we are saying that we have a sensor imagery which is working upon 8-bit system. So 2 to the power 8, that means 256 shades. And suppose that sensor is giving details in 3 bands, red, green and blue. So there will be 256 shades for red, 256 shades for blue and 256 shades for green. So this much shades will be incorporated in the image for the viewer's discretion. Now, after that, we will move on to temporal resolution, as the temporal has derived its name from the term time. So, the basic principle working behind temporal resolution is time. We can refer or we can describe temporal resolution as revisit time. Now, the top concern is that what is revisit time? Suppose satellite A is capturing the data of Almora at 9 p.m. today, and that satellite captures the data of Almora next time on tomorrow at 9 p.m. correct sharp. Then the temporal resolution take for that particular satellite, for satellite A, will be 24 hours. Why 24 hours? Because that particular satellite has revisited Almora city exactly at 24 hours. So this is the concept of temporal resolution or the revisit time period. Time taken by a particular satellite to visit a particular area consecutively is known as temporal resolution. Temporal resolution for some satellites can be some hours, whereas some day as well as some days. Temporal resolution for Landsat imagery is 16 days, whereas MODIS captures the data continuously or daily. So the temporal resolution for MODIS is 24 hours. So this is all for today. Here is a picture which shows the comparison of resolution in Landsat series. In Landsat 4 and 5, the spectral resolution is 7 bands. Spatial resolution is 30 into 30 meter for all the bands, whereas 120 into 120 meter for thermal infrared. Temporal resolution, aka revisit time, is 16 days. Spatial coverage is 185 into 185 meters. Altitude is 705 kilometers. In Enhanced Thematic Mapper Plus Landsat 7, the spectral resolution is 8 spectral bands. Spatial resolution is 15 into 15 meter for pan, that is panchromatic band, 30 into 30 meter for all other bands, and 60 into 60 for thermal infrared. Temporal resolution or revisit time period is 16. In multispectral scanner, means Landsat 1 to Landsat 5, the spectral resolution is 4 bands, that is green, red, NIR and NIR. Spatial resolution is 79 into 79 meter. Temporal resolution is 18 meter. In next session, we will discuss about some other basis upon which the types of satellites are divided. Under it, Earth resource satellites is incorporated and meteorological satellites is incorporated. After that, we will also look upon some satellites like Landsat, Spot, etc. And we will also look at the specifications of those satellites. So that's all for today. Thank you so much.